Welcome, scientists, geneticists, and enthusiasts alike. We are here today to present our cost-effective PCR machine to the general public. Our initiative is to solve a major problem in today's lab equipment market, which is that most pieces of lab equipment simply cost too much money for the general public and low-budget consumers. Today, we created a cost-effective PCR machine that is 50 times cheaper than today's lower-tier commercial-grade PCR machines, yet it's just as effective. A PCR machine, also known as a thermocycler, is one of the most essential machines in the genetics lab. You might ask yourself, what is a PCR machine? Well, a PCR machine is, in essence, a DNA copy machine. In order to analyze a specific section of DNA, it is much easier to examine it if you have a larger sample pool. One piece of DNA is extremely small and very difficult to analyze. This is where the PCR machine comes into play. Through the use of one strand of DNA along with DNA polymerase, the DNA will be copied every time it cycles. What are cycles, you may ask? The machine cycles through a series of heating and cooling events, approximately 30 times for each set of samples that you process. As the DNA strand heats up, the double helix splits into two separate strands, and as it cools, it replicates itself. Thus, by the end of the cycle period, it duplicates itself tens of thousands of times, thereby creating the large sample pool that the user needs, making for an easy analysis. You might ask yourself, what are the advantages of our product compared to the others? It's quite simple. For one, ours is significantly more affordable than your standard PCR machine, yet it's just as capable. Even a basic model goes anywhere from $5,000 to $10,000, while we built our machine for under $200, which is 50 times less than the cost of commercial machines. Additionally, modern PCR machines have an unfriendly user interface with a high learning curve to operate, even though one might expect that they would have a more friendly user interface given their high price. We solved this by creating ours with a simple yet effective user interface that almost anyone can use. Lastly, when a toaster oven is done, it dings, and when your clothes dryer is done, it buzzes. One might expect this simple yet important feature to be available on the commercial grade machines, but they are lacking them. We have added this feature to our machine, making our design superior to the others. Now, you might ask yourself, that sounds all fine and dandy, but how does it work? It's very simple. For cooling and heating, we use a device called a Peltier tile. A Peltier tile is basically a ceramic tile that is filled with silicon semiconductors. When current is sent through the tile, one side absorbs heat and the other side releases it. Thus, one side gets hot and the other gets cold. The direction of the current itself determines which side becomes hot and which side becomes cold. Using the Peltier effect, we are able to efficiently heat and cool the device. The design is very simple. The heating block, which holds the samples, rests upon a Peltier tile, which then rests upon a heatsink that is cooled by a fan. The Peltier tile is connected to an H-bridge module that is controlled by an Arduino. An H-bridge module allows us to control the direction of the current, thus allowing us to use only one Peltier tile for an efficient heating and cooling of the heating block.